Reading a measuring tape is a foundation skill in most of the trades, and yet many adults struggle to read a measuring tape. And the reason is it's quite a complex task. You need lots of different skills all working in conjunction to do it. For example, you need to know how a measuring tape works, you need to know place value, tens and hundreds and so on, you need to know about decimals, and you need to have the spatial awareness to know that what you're reading is actually what you are measuring. So what goes wrong? Well, for adults who do struggle with this, usually it's a lack of familiarity with the tool. To give you an example, there are things called signal points. So this is 85.5 centimeters. Now you'll notice that you have to read the 80 first. It's in red, that's a signal point, and you have to know that it doesn't go 80, 81, 82 in numbers, but rather it shows you the 80 and then you have to go 1, 2, 3, 4, 5, 85. Now many learners who make mistakes, they go 80 and 5 and read it as 805. So there's one thing that many learners make a mistake with. And then you have to read the millimeters, so you have to count the 5 millimeters and you have to go 85.5 centimeters. Now, perhaps you have to convert that into millimeters, in which case you need to know about timesing it by 10, 855 millimeters. Now, most of this is done under pressure. The boss is asking for a measurement, or you're trying to measure and cut something, so the pressure's on that you get it right. So you get pressure, lack of familiarity with the tool, and the complexity of the numeracy, and it all kind of compounds to make it a difficult task for a learner. So what do we do? So here are 4 skills in the order of their development that learners need to be able to read a measuring tape. Number 1 is they need to develop an internal representation of how long a meter is, a centimeter, and a millimeter. That means they have to have an idea in their head of how long those things are. So you might ask a learner, what's something that's roughly a meter long? And you should be able to do this too. Well, a guitar is roughly a meter, or such and such is roughly a meter. You should know in your head and then be able to apply it to things in the world. So here's a really good way to do it. First of all, just ask the learner, hey, show me with your hands how long you think a meter is. And you'll see straight away what their internal representation of a meter is. So they might go about this long, you know, whatever. Usually it's shorter than what an actual meter is. Here's a quick way to help them develop it. Give them some masking tape or some tape and say, okay, I want you to pull this out and cut it to exactly 1 meter length to what you think is a meter. So they pull the masking tape out, cut it, stick it to the ground, and then say, hey, okay, let's measure it with a measuring tape. Then you measure it and they will see instantly that it's either shorter or longer, and then get them to do it again with a piece of masking tape that's 1 meter and stick it next to that one. This instantly helps them get a sense of, you know, oh, that's what a meter is. And the next thing you do is you pick a distance, say from here to the wall or the height of a wall, and you say, how many of those do you think it would take to run that distance? Or how many of those meters would fit within that? So you're teaching them to visualize that length against the floor and so on, and then you measure it. And what you want to do is you want to get them to practice that as much as possible, guessing how many of those meters that are in their head would fit on that wall, and then measure it. That's what you want. Now, a quick note on neurodiversity. This is the key area where somebody with dyscalculia will have difficulties, the spatial awareness of length. But really, it's just a matter of more time on task. There's nothing really different here. It's just going to take more practice. So that's it. You show them the meter, and then you get them to mentally think about how many of those it would take to fill a space. Number 2, show them how measuring tape works in regards to those signal points. So for example, they only write tens and hundreds just because of space. So here's 80. So show them that it goes 80 and then you read up 81, 82, 83, and so on. 83 is not 80 and 3, 803. You'll be surprised at how many learners are not sure about this. It's a little bit confusing, so just showing them that you read up the measuring tape and count. Number 3, get them to measure things and then say it aloud. They may not like this, but this is the best way to learn. So for example, if the measurement is 5.4 centimeters, get them to measure it and say 5 centimeters and 4 millimeters. And then you write on a whiteboard or something 5.4, and you would say to them how to say it, 5.4 centimeters. So they can say it in the full units to get a handle on what's going on, and then you show them how to say it in numbers. And this will change really quickly, like this will be a quick learning curve for them. So our next skill is to help learners convert between centimeters, millimeters, and meters. Now, I can hear all the carpenters and builders screaming at me that they work in millimeters and that their learners will just have a measuring tape with millimeters. I hear you, yes and no. It is not unreasonable to expect adults to be able to read a measuring tape made up of meters, centimeters, and millimeters. The low expectations for numeracy skills is not helping anybody, even though carpenters and builders and other people might choose to use millimeters out of convenience because they're primarily measuring in millimeters. But we should be teaching adults to be able to read a measuring tape in any format. Here's how you do it. First of all, get yourself one of these things. They're really easy to make. You can just cut them out of paper. They're called decimal sliders, very useful. And what you do is you just put your numbers in there, for example, 22.5 centimeters, and then we just slide it out using this place value chart, and they can see that that's 225 millimeters. 32.3 centimeters becomes 323 millimeters. We can do it with meters as well, so we might have, for example, 1.34, then that becomes 134 centimeters or 1040 millimeters. You can even do it backwards if you wanted. You might, for example, have 333 millimeters. That would become 33.3 centimeters, and so on. So with this little tool, you can just move the numbers back and forward. And the idea of this tool is that the learners see it, and then they internally represent it. They make an internal representation in their minds so they can actually mentally do it. So if you transition from the tool to the mind, it happens really quickly and learners get very good at this. So to summarize this, number one, internal benchmarks. How long is a meter? Get them to make it with a bit of tape and then walk around and think how many of those will fit in that area. Develop internal benchmarks. Number two, teach them how a measuring tape works. Signal points, reading up the measuring tape. Number three, get them to say it aloud as much as possible. And if they're really at the early stages of mastering this, just get them to say the full units, 4 centimeters, 5 millimeters, and then show them 4.5. That's how you do it. And the final thing, use one of these decimal sliders to help convert between the units. It doesn't take long. Learners get it really quickly. Now, if you'd like more information on any of this, this is a once slightly over, you can contact me or contact Ako Aotearoa, and we can do more in-depth work around this. But just by applying these 4 things, you'll really be able to improve your learner's ability to read a measuring tape in no time. Hope this was helpful. Thank you.